It is April 1st, 1990. Strangeways Prison, Manchester, England. Not a Tuesday with a grudge. Not an organized breakout. Just a Sunday chapel service, wooden pews, hymn books, 200 men who have been told to sit quietly, and then, in the space of 90 seconds, one of the largest prison riots in British history ignites from nothing. 25 days. 47 injuries. 1 inmate dead. A rooftop siege watched by the entire country on live television. And at the end of it, investigators would ask the same question they always ask. Why? The answer they found wasn't gang politics. It wasn't a single guard's cruelty. It was something so foundational, so biological, that it rewrote how forensic scientists think about violence. It was lunch. Pause and consider. You are about to learn that some of the most violent incidents in the modern prison system may have been influenced not by hatred or desperation, but by a molecule your body produces after every meal. HM Prison Manchester, known to locals simply as Strangeways, opened in 1868. By 1990, it was designed to hold 900 inmates and was housing over 1,600. Overcrowding was systemic. The diet was institutional. Breakfast, white bread. Tea with processed sugar. Lunch, tinned goods, starchy sides. Dinner, the same rotation, heavy on refined carbohydrates, almost entirely devoid of essential fatty acids, micronutrients, or dietary fiber. The kind of menu that, in a hospital, would trigger a nutritional intervention. On April 1st, the daily meal had been served. 2 hours later, the riot began. Forensic psychologists reviewing the incident would later note something that had been hiding in plain sight in incident reports going back years: the clustering of violent outbreaks in the hours immediately following meals high in refined sugar. Not during meals. After them. Think back to the last time you felt genuinely irritable after eating fast food, that foggy, edgy crash a couple of hours later. Hold that sensation. We are going to follow it all the way to a cell block. To understand what happened at Strangeways, and what the data would confirm in laboratories 20 years later, you need to understand one fact about the organ inside your skull. The human brain accounts for approximately 2% of your body weight. But at rest, it consumes roughly 20% of all the glucose your body produces. It is the most metabolically expensive structure in biology. And unlike your muscles, it cannot store its own fuel reserve. It runs, moment to moment, on whatever glucose your bloodstream is supplying right now. That dependency is the key to everything that follows. The prefrontal cortex, the PFC, sits just behind your forehead. Neuroscientists sometimes call it the CEO of the brain. It is responsible for impulse control, consequence evaluation, the ability to pause before you act. It is what allows a person to feel rage and still choose not to swing. Research shows that the PFC is the first region to lose function when blood glucose drops. It is, in neurological terms, a luxury. When energy becomes scarce, the brain deprioritizes the structures responsible for restraint. What remains fully powered? The amygdala, a small, almond-shaped structure deep in the brain's core. It processes threat. It has no capacity for consequence. It does not know the difference between a man stepping on your shoe and a man holding a weapon. It simply fires, danger, respond, now. When the PFC dims due to metabolic stress, the amygdala does not dim with it. It continues operating. And in an environment like a prison, where territorial threat is ambient, where eye contact carries meaning, where every interaction has a hierarchy, the amygdala without its regulator is not a scared brain. It is a trigger. The body's response to low blood sugar is automatic. It releases adrenaline and cortisol, the hormones of the fight or flight response, to mobilize stored energy. In a biological sense, this is the body trying to save itself. But cortisol also heightens threat perception. It makes everything feel more dangerous. Combined with a depressed PFC and an active amygdala, you now have an organism that reads minor provocations as existential, cannot rationally override that reading, and is flooded with the chemistry of combat. In a cell with nowhere to flee? That is a volatility window. And prison researchers had found it hiding in the daily meal schedule. Have you ever made a decision you regretted when you were hungry, genuinely, physically hungry? Pause and consider, what you experienced was a mild version of this cascade. Now imagine it in a prison with no exit. Here is the mechanism that made Strangeways not just possible, but almost predictable. When a meal is high in refined carbohydrates, white bread, processed sugar, sweetened drinks, blood glucose spikes rapidly. The pancreas responds with insulin. Glucose is cleared. What follows is a crash. Blood sugar drops below baseline. The hypoglycemic window opens. Now introduce the prison commissary. In most prison systems, the inmate store, known in the UK as the canteen, in the US as the commissary, is the primary supplement to institutional meals. Analysis of what sells best in these stores is consistent across systems. High-sugar confectionery, sweetened drinks, white flour biscuits, and snacks. Researchers studying this pattern, including the work of Dr. Stephen Schoenthaler at California State University, documented what he described as a self-medication loop. Inmates experiencing the mood-depressing effects of the glucose crash would reach for a high-sugar snack to lift their mood rapidly. The snack produced another spike, and then a deeper crash, a second volatility window, and in some cases, a third. Incident reports from multiple facilities showed a consistent pattern: violent events clustered in the 2 to 4 hour window following canteen access. Not during canteen, after it. In the late 1990s, a research team led by Bernard Gesch at Oxford University decided to test the hypothesis directly, not with historical records, but with the gold standard of medical evidence: a double-blind, placebo-controlled trial. The location: HM Prison Aylesbury, Buckinghamshire, a young offender institution housing adult male inmates. The population was selected specifically because of the high baseline rates of disciplinary incidents and violence. 231 young adult male prisoners were enrolled. One group received a daily capsule of vitamins, minerals, and essential fatty acids, nutrients that stabilize metabolic function. The other group received an identical placebo. Neither the inmates nor the staff recording disciplinary incidents knew who was receiving which. The results were published in the British Journal of Psychiatry in 2002. They caused immediate controversy in criminology, not because the findings were weak, but because they were uncomfortably strong. Inmates receiving the nutritional supplement committed 26.3% fewer total disciplinary offenses than those receiving the placebo. When the researchers isolated serious violent incidents specifically, the reduction in the supplemented group was 37%. The placebo group, same facility, same guards, same rules, showed no meaningful change. Gesch was careful in his conclusions. He did not claim that diet causes violence. He argued, precisely, that nutritional deficiency may remove a physiological buffer that normally moderates the threshold at which a person acts on impulse. That buffer is the prefrontal cortex, and the nutrients most critical to its function, omega-3 fatty acids, zinc, magnesium, B vitamins, were precisely what was missing from the standard institutional diet. The inmates in that study did not know who was getting the supplement and who was getting the placebo. Neither did the staff recording incidents. And yet the numbers diverged: 37%. Pause and consider what it means that something invisible in a capsule changed the violence rate on a cell block. Across the Atlantic, a parallel body of evidence was accumulating. Dr. Stephen Schoenthaler at California State University had spent the 1980s and 1990s conducting dietary intervention studies across American juvenile facilities, eventually encompassing data from over 3,000 young offenders. The Tidewater, Virginia study became one of the most cited examples. Unlike the Gesch trial, the Tidewater intervention did not add supplements. It removed products. Refined sugar was replaced with fruit and whole grain alternatives. Sweetened drinks were replaced with juices. The shift was dietary, food policy, not pharmacology. The reduction in antisocial behavior within the first 3 months, 47%. The intervention was controversial for reasons that had less to do with the science than with its implications. If diet could shift behavior by 47%, what did that say about culpability? What did it say about punishment models built on the premise that antisocial behavior is purely a matter of moral choice? These were not questions the American justice system was eager to examine. The Gesch study in the United Kingdom found a 26.3% reduction in total offenses and a 37% reduction in violent incidents. The Schoenthaler work in the United States found a 47% reduction in antisocial behavior. Same hypothesis. Different continents. Same direction. Here is the question the data leaves you with. If a hospital were shown that a dietary intervention reduced patient harm by 37%, how long before that intervention became standard of care? Pause and consider why a prison might be different, and whether that difference is justified. If a randomized controlled trial published in one of psychiatry's most respected journals showed a 37% reduction in prison violence by addressing nutrition, and if parallel American data pointed in the same direction, the reasonable question is, why, more than 2 decades later, are prison diets largely unchanged? The answer is not a conspiracy. It is a budget logic, and budget logic in public institutions can be harder to shift than ideology. Providing nutritionally stable meals, adequate protein, complex carbohydrates, essential fatty acids, micronutrients, costs roughly £1.50 to $2 more per inmate per day than standard institutional fare. In a facility of 1,000 inmates, that is between $500,000 and $700,000 annually. For a prison system already under budgetary pressure, that number sits at the top of the ledger where decision makers can see it. It is concrete. It is immediate. What sits below the ledger, invisible until something goes wrong, is the cost of a single serious incident. A major disturbance requiring emergency response, medical attention for injured staff and inmates, facility repairs, administrative investigations, and overtime pay can cost a facility anywhere from hundreds of thousands to millions of dollars. The Strangeways riot cost an estimated £60 million to address, in 1990 money. The preventive cost was never calculated, because prevention was never the frame. There is a second economic layer. In many prison systems, the inmate commissary, the store where inmates purchase supplementary food, is a revenue-generating operation. The products that sell best and generate the most margin are the same high-sugar, low-nutrient items that the nutritional research suggests may be elevating violence rates. This is not, to be precise, a coordinated plot. It is a structural conflict of interest. The system is not designed to harm. It is designed to balance books. But the outcome, viewed through the lens of the data, is the same. Despite these findings, implementation of nutritional standards based on the Gesch and Schoenthaler models remains rare across prison systems globally. The science did not fail to persuade. The economics did not allow the persuasion to matter. We began with a riot. 25 days of chaos at Strangeways started for reasons that no single investigator could fully explain. We will never know with certainty what role glucose metabolism played on that chapel floor in April 1990. But here is what we do know. We know that the prefrontal cortex, the brain's instrument of restraint, is the first system to degrade when blood glucose becomes unstable. We know that the amygdala, the brain's instrument of threat response, does not degrade with it. We know that in a randomized control trial, addressing that nutritional gap reduced serious violent incidents by 37%. We know that a parallel dietary intervention in the United States produced a 47% reduction in antisocial behavior across thousands of juvenile offenders. And we know that 20 years after those findings were published in peer-reviewed literature, the standard prison diet in most countries remains functionally unchanged. The forensic lesson here extends beyond prison walls. The brain under nutritional stress, any brain, is a brain with a shortened impulse threshold. You have almost certainly experienced a version of this. The irritability of genuine hunger. The poor decisions made when exhausted and underfed. The disproportionate reaction that, in retrospect, you could not fully explain. What the prison data tells us is that this is not weakness of character. It is biochemistry, and biochemistry, unlike character, can be measured, predicted, and intervened upon. The red flag is not a type of person. It is a state, metabolic, physiological, and entirely addressable. The question that the data demands we ask is whether our institutions are structured to address it. Most of them are not.